Today I'm going to teach you guys how to solve the AP 2014 question 3 on the exam. We are given that f is defined in the closed interval from -5 to 4, and also the key fact that g of x is equal to the integral from -3 to x of f of t dt. Part A asks us to find g of 3. Using the g of x from the original part, g of 3 would simply be equal to the integral from -3 to x3 of f of t dt. Next, we will use the graph to find the area underneath the curve, as that is what the definition of an integral is. Using the graph and knowing that we need to find the area underneath the curve from -3 to 3, we can simply split this into 3 triangles. The first triangle we will look at is right here. And because we know how to find area of triangle is simply 1/2 base times height, we can solve. This part is 3, the height is 4, and using 1/2, 3 times 4, we get 6. So the area of this triangle is 6. This next triangle is what we're looking at here. We have the same height of 4, but instead the base is 2. So 1/2 times 2 times 4 is 4. This part of the triangle on the graph is a little bit harder. We know we need to find 2, 3, so we'll draw this line here. So it is basically this triangle. We do know that the base is 1, but we may have some trouble finding the height because we cannot just assume that is at -2. So, because we are given 2 points, 4, -4, and 0, 4, we can find the slope of this line. 4 minus -4 over 0 minus 4. So the slope of this line is -2. And using point slope form to find the equation of that line, y minus 4 is equal to -2 times x. So y is equal to -2x plus 4. Because this is equal to 3, we can simply plug in this x value. So -6 plus 4, y is equal to -2. Thus, our height is -2, or just 2. And using the equation 1/2 base times height, we get the area of this triangle to be 1. Finding g of 3 becomes fairly simple at this point because we know the areas of all 3 triangles. The first one is 6, added to the second one of 4, while the area of 1 is subtracted since that triangle's area was below the x-axis. So your final answer for g of 3 would be equal to 9. B of the question asks us to find where the graph of g is both increasing and concave down. To do so, we can use a number line. The first number line will consist of the function of f of x, or f of t in this case. We will select the values that are seen on the graph. So -5, -3, 0, 2, and 4. The f of t value we will be looking at is where it is above the x-axis on the graph. So from -5 to 3, we see it as positive. From -3 to 0, still positive. From 0 to 2, still positive. But 2 becomes a crucial point as it goes into the negative values. Next, we're going to make the graph of f prime of x. Using the same exact values as the first. But because f prime of x is also the slope, we'll be looking at the slope vectors on the graph. So from -5 to -3, we can see that the slope is negative. The slope from -3 to 0 is positive. The slope of 0 to 2 is negative, and the slope of 2 to 4 is still negative. So eventually solving to find where it's both increasing and concave down comes into the play of a velocity and acceleration graph where these symbols will be opposite. So we're going to look for sections that line up from the two number lines that have opposite signs. So from -5 to 3, we can see opposite signs, and also 0 to 2. Thus, our final answer would be -5, 3, union 0, 2. Part C of the question gives you h of x is equal to g of x divided by 5x. And we are asked to find h prime of 3. So the first step will be finding h prime of x. And using the quotient rule, we can find this. G of x, 5x, 5. Using the quotient rule again, g prime of x times 5x minus 5g of x divided by 5x quantity squared. So now we have found h prime of x, but because we need to find h prime of 3, it becomes fairly simple. All we need to do is plug in the 3 for the x values. So we have g prime of 3 times 15 minus 5g of 3 divided by 15 squared. Now, we need to solve the values for g of 3 and g prime of 3. G prime of x is also equal to f of x. And f of x plugged in, looking at our graph from what we solved for in parts A, we find this value to be equal to -2. And in part A, we already solved for g of 3, which is equal to 9. So all we must do is plug these values in. So, -2 times 15 is -30. 9 times 5 is 45. And 15 squared is 225. So we have -75 divided by 225. And simplified is equal to -1/3. Part D of the question gives us that p of x is equal to f of x squared minus x, and asks us to find the slope of the tangent line to the graph of p where x is equal to -1. And as we know, the slope of the tangent line is also known as the derivative. So we're going to find the derivative of p of x. So p prime of x is equal to f prime of x squared minus x, and using the implied chain rule, multiply that by 2x minus 1. The problem is asking us where x is equal to -1. We will simply plug in the values. So it will be f prime Solving this, we get f prime of 2 times -3. So now the final part is simply solving it. F prime of 2 is the slope where x is equal to 2, as we used in the graph earlier. And what we solved for was that f prime of 2, that slope of that line, is equal to -2 times -3, and our value is equal to 6. As you can see, quite a bit of work goes into just solving 4 parts of a question. They give us information on purpose and want us to use it, such as the g of x value. It's also important to remember to take parts from A, possibly, that can be used in B, C, and even D. Thanks for watching.